Hello and welcome to Learn Yourself. Today we are going to learn about language of chemistry. This chapter is under ICSE Std-9 syllabus. So here I have made one flow chart and I have shown some of the important points which we are going to cover in this chapter. Some of the basic concept we have already studied in Standard 7 and Standard 8. Here we are going in little bit depth and we will learn that how we will be able to form a molecular equation from molecular formula and how the molecular formula will be formed from the ions. Why the symbols are important and so on. So let us start with a basic knowledge of our chapter. First we are going to study about the symbols. So what are the symbols? For example, if I'll say potassium, then K is a symbol for potassium. Then calcium, nitrogen, oxygen, carbon and so on. There are so many different elements and each element has a particular symbol assigned to them. We need to remember all these symbols and their atomic number. Some of the ions are positive. From the symbols we are writing ions. Some of the ions are positive ions. And some of the ions are negative ions. With hands-on experience and with practice, you will automatically remember that this ion is positive and this ion is negative. It is depending upon their valence shell, and valence shell, how we are writing atomic or electronic configuration, it is depending upon the atomic number. So to study this chapter or to remember this chapter and to understand this chapter, the following points you need to by heart, you need to remember. First, symbols of almost all elements in the periodic table, whatever we are using maximum. Then, according to the elements, the atomic number of those particular elements. It is very important because from the atomic number we are writing electronic configuration, and from the electronic configuration we are going to decide whether this element is positive or negative. So positive and negative, and from there their valency. So their valency is 1, 2, or sometimes they are showing 2 different or 3 different valency, and the reason for the same. Then after writing ions, after writing all this, we are going towards the molecular formula. 2 ions combine together or 3 ions combines together and will give us compounds. How we are writing the compound? For example, NaCl. This is a compound. One positive ion and one negative ion. Both will combine and form compound. So how many things we need to remember here? Valency, then their positive character or their negative character, and from that we can form molecular formula. Why we need molecular formula? To write equation. Now there are 2 types of equation. One is word equation, then second is molecular equation. Word equation means when we are writing in words, sodium chloride. So this is our word equation. But when we are writing molecular formulas, it is going to be molecular equation. And then very important thing is balancing of equation. So all these points we are going to study in this chapter. So in my previous video, I have shown a flow chart that in this particular particular chapter, what all basic concept we are going to study. So before watching this video, please look into that video and understand that what all things we are going to study in this chapter. Let us start with iron. So there are two types of iron. One is positive ions and another one are negative ions. As name suggests, the positive ions are having plus sign on their top, and this shows the valency. Where only plus sign is there, it shows the 1. So that means the valency of sodium is 1. The potassium valency is 1. Magnesium is divalent and its valency is 2. But it is positive ion, so that's why we are representing it with plus 2. Plus suggests that whether this ion is positive or negative. So this ion is positive. Then 2 suggests us that what is the valency of that particular ion. This is aluminium. It is positive and its valency is 3. Now negative ions, chlorine, oxygen and nitrogen. They all are negative, so negative sign is there. Here 1 is there, that means its valency is 1. Oxygen's valency is 2 and nitrogen's valency is 3. But they are negative, so we are representing it with -2, -3, -1. If you will see that sodium and chlorine, if we will say that valency for sodium and chlorine is 1. Valency will remain same for sodium and chlorine, but the sodium is positive ion whereas chlorine is negative ion. Similarly, valency for magnesium and oxygen is 2, but magnesium is positive ion whereas the oxygen is negative ion. And similarly for aluminium and nitrogen. So from this ion, we are going to write a molecular formula. If you have any doubt that how the Na1 plus is there and Cl1 minus is there, then please check my video based on electronic configuration of standard 8. It will cover how to write electronic configuration, what is the valence shell and how we are determining valency for each and every element. If element is donating electron, it will generate positive ion. If element is accepting electron, then it will generate negative ion. If you have doubt regarding all these things, then please check my video based on this topic from the standard 8. This we have already studied in standard 8. So from this, we are going to form a compound. So the first step is ions, second is compound. So how we are going to write a compound from this two ion? So how we can write a molecular formula from two different ions? Suppose I have Na plus and Cl minus. Its valency is 1, its valency is 1. Na's valency is 1 and Cl valency is 1. So with cross multiplication, I am going to write it here NaCl. One more example, aluminium and Cl. Aluminium is positive and Cl is negative. So aluminium's valency is 3, whereas Cl's valency is 1. So by crisscross method, we are multiplying this and we are going to write a molecular formula that AlCl3. So if you have any doubt regarding this is just a recapitulation of what we have studied in standard 8. Then please check my video based on how to write molecular formula. All the links of this videos have been given in the description. So far we have studied that from the ion through their valencies we have formed a compound. So till now we have seen that how we can write a molecular formula from the ions. So what is our molecular formula? Whatever we are writing a molecular formula, in turn we are writing a molecular formula for a particular compound. So if we are talking about compound, then let us discuss the characteristic of compound. What is a compound? This characteristic of compound we will understand with a very basic compound, H2O. With reference to H2O, we will try to understand the characteristic of compound, or you can say the characteristic of H2O. This characteristic will impose to all compound and whatever compound is existing. So the compounds are pure substance. When they are made, it is different that if some effluent is or some impurity is mixed with that. We are not talking about that. When we are making a compound, when the compound is there, it is a pure. It is a pure substance. All the compounds are pure. Then second, it is made with two or more elements. If you will see here, how many elements are there? First, hydrogen is there and oxygen is there. There are so many other compounds which are made with two or three elements. So here our compound is made with hydrogen and oxygen. So there are two elements which has made this compound. So the second characteristic of compound is it is made with two or more elements. It is combined in a fixed proportion. If we are talking about water, then the ratio of hydrogen and oxygen is fixed. The two atoms of hydrogen will mixed with one atom of oxygen, and this proportion is fixed. If you will write H2O2 or HO2, then that is not our water. That can be another compound. Maybe it is existed, but that is not a water. So if you are particularly talking about one specific compound, then it has to be combined in fixed proportion. All the compounds are in fixed proportion. It is homogeneous. They are mixed well. Earlier we have seen this heterogeneous and homogeneous. Those things also can be applied to a mixture. But when we are talking about compound, they are chemically mixed. It is not a mixture. They are chemically mixed and you cannot segregate it with any physical matter. You need to have some chemical process, then only you can take out any atom or molecule out of it. Then last one is it has a definite set of properties. Each and every compound shows some particular properties. They have some fixed melting points, some fixed boiling points. They show some physical characteristic, they show some chemical characteristic. So they have some definite set of properties. So these are the characteristics of compound, and it is very easy. There are 5 basic main characteristics of compound. Some of the important compound and their formulas. So how we are going to name a compound? We will remember it, or we will learn it by remembering all this ions name, ions chemical name. In this you are going to learn so many compounds. From those compounds you are going to write molecular formulas. From molecular formulas you are going to write equation, and from equation you are going to balance an equation. So in this series of doing doing so and so things. The first step is you have to write correct molecular formula. For that, you have to remember some of the ions name. It will be very easy when it is positive ions, because positive ions are always come from the metals: sodium, aluminium, potassium, calcium, and so on. So it is easy to write the name of the positive ion which comes first. But the second ion is negative ion, and sometimes there are polyatomic ions. If it is like a single ion, then it is easy: chloride, bromide and iodide. But if they are polyatomic means it has more than one atom, 2 atom, 3 atom and so on. So this kind of negative ions have specific names. So we have to use this particular name for our compound. Let us understand one by one, and if you will see it in a particular sequence, then it will be very easy to remember. First is carbonate. If you will add H with it, it will be bicarbonate. Wherever H will come in front of the negative ion, you have to write prefix bi. So this is bicarbonate. And along with this, you have to remember their valencies, because when you are writing molecular formula via crisscross method, we have to cross multiply it with the positive ion. So this is bicarbonate. CO3 is carbonate. When H will come here, it will become bicarbonate. Carbonate's valency is -2. But when it is reacting with H, one of its valency will go and react with hydrogen. So its valency will be -1 and not -2. So this is carbonate, this is bicarbonate. It is losing its one valency to hydrogen. So this is -1 and that is bicarbonate, this is carbonate. For sulfur, we have this 3. If it is SO4, then it is sulfate. When it is S-2, it is sulfide. When it is SO3, it is sulfite. ITE, IDE and ATE. You have to remember this, and all this have -2 valencies. Now these are halides: chlorine, bromine, iodine, and they all have -1 valency, and we termed it as chloride, bromide and iodide. Now like this, if it is sulfide, when we are adding H, it will become bisulfite. This is -2. It is reacting with hydrogen, so it has one less valency compared to this. One less combining capacity compared to this. Now coming towards N. So if it is NO3, it is nitrate. If it is NO2, it is nitrite. If it is N-3, it is nitride. And if it is O, then it is oxide. Now whenever this negative polyatomic ions are reacting with our positive ions, then let us take one example, that Na. Na is positive ion. It has one valency. When it reacts with HCO3, so it will become HCO3. What is the valency? It is -1. So 1, 1 via crisscross method, it will become NaHCO3. Now when we are writing a name of any particular compound, how we are going to write? This we know is sodium, and from this we know it is bicarbonate. So the name of this compound is sodium bicarbonate. Now let us go towards the second one. The same way, sodium will react with carbonate, then it will become sodium carbonate. When sodium will react with sulfate, what will be the molecular formula? NaSO4. It is 1, it is 2. By a crisscross method, it will become Na2SO4. What will be the name? Sodium and sulfate. Sodium sulfate. If it is NaS, then it will become sodium sulfide. Sodium sulfite. Sodium chloride, sodium bromide, sodium iodide. Then sodium bisulfite. Then similarly with each and every positive ion you can add this. If it is calcium, calcium's valency is 2 and here it is nitrate. So NO3 and 1 valency. So CaNO3 twice. This 2 will go here and this nitrate will go in bracket because we have to write the 2. The CH valency will go along with nitrate. Calcium nitrate, calcium nitrite, calcium nitride, calcium oxide, sodium oxide and so on. So this is the way you are writing a name of a compound and you can frame a molecular formula like this. But the important step is you have to remember the name of the polyatomic ion and their respective valencies. In standard 8 we have already learned that how to balance a chemical equation. Here we are revising the concept and the chemical equation which we are going to solve will have a +1 difficulty level compared to standard 8. So let us quickly revise it and we will solve some of the important questions regarding it. So here I have mentioned one equation. Potassium when react with carbon dioxide, it will give us potassium oxide and carbon. So what is our first step to balance an equation? That we will write all the atoms from reactant side and from product side. So we have here potassium, carbon and oxygen. We have 1 potassium, we have 1 carbon and we have 2 oxygen. Where in product side we have 2 potassium, 1 carbon and only 1 oxygen. So we need to balance here potassium and oxygen. Let us first balance the oxygen. First we will balance oxygen. Here oxygen are 2 whereas here oxygen is 1. The first rule of balancing of equation is you cannot add anything over here. This is wrong. You cannot add anything here down. If you want to add, you can add here. That means you can add only molecule. You cannot add any atom. And practically to add 1 atom into a reaction, it is not possible. So you cannot add any atom. Always you can add in front of the reactant or product. Here you cannot add anything. So you cannot add here 2. Always you have to add a whole number over here. So we have to balance this oxygen. So we have this side 2 oxygen whereas here we have only 1 oxygen. So if I will add here 2, so my oxygen is balanced from both the sides. 2 2. My oxygen is balanced. But now my potassium has changed, that it has become 4 over product side, but whereas at the reactant side it is only 1. So if I will add here 4, then my potassium will also balance, and here no need to balance because carbon is 1 and carbon is 1 here. Let us calculate again this 4 potassium. Yes, 2 into 2. Now whenever you are adding 2 and K and 2, then this 2 and this 2 you have to multiply. That many amount of that atom is there in your reaction. So 2 into 2, so 4. So our potassium is balanced. Now carbon. Carbon we have here 1 and here also it is 1. So it is also balanced. Now oxygen. 2 oxygen is here and this 2 goes with this oxygen also. When we are writing 2 K2O, then this 2 will apply to this and this 2 will apply to oxygen also. So for K we are multiplying 2 into 2 and for oxygen it is only 2O. It is like this. So this 2 will go with oxygen. So how many oxygen we have? We have 2 oxygen. 2. So oxygen is also balanced. So our equation is balanced. So balanced equation is 4 potassium plus carbon dioxide gives us 2 molecules of potassium oxide plus carbon. This is our balanced equation. Now let us solve some of the questions. We will solve first question. Here in the equation it is iron chloride, then chloride will give us iron chloride. This is iron 2 chloride, this is iron 3 chloride. So this is ferrous chloride, this is ferric chloride. So in this, let us see that how many ions we have. So Fe we have 1, Cl we have, whenever it is like this, you have to add this to Cl. So 2 plus 2. So how many total Cl we have? 4 Cl towards reactant side. Now towards product side we have 1 Fe and we have 3 Cl. So first let us try to balance chlorine. So if I will add here 2, if I am adding here 2, then how it is going to change? Fe will become 2 now and Cl will become 2 into 3. So Cl will become 6. Now Fe is 2 and Cl is 6. So here we have Fe1 and Cl4. If I will add 2 here, then now my Fe is 2 and how many Cl's I have? 2 into 2. So 4 Cl plus 2. Here it will become 2 into 2 and this plus 2. So how many Cl I have? 4 plus 2, 6 Cl. So 2 Fe and 6 Cl. So my equation is balanced. So what is my balanced equation now? 2 Fe Cl2 plus Cl2 gives us 2 Fe Cl3. Whenever you are balancing an equation, you will not get correct answer in first try. By trial and error, you are adding a molecules over here toward product side or toward reactant side and you will get correct answer. So with little bit more practice, with hands-on experience, you will get this. But the practice is very important in balancing of an equation. Second equation. In second equation, the equation is calcium hydroxide will react with nitric acid and gives us calcium nitrate and water. So let us note down all the atoms towards reactant side and towards product side. So first, calcium, oxygen, hydrogen. Hydrogen we have already written, oxygen we have already written, so remaining is nitrogen. So how many calcium we have? 1 calcium, oxygen, 2 oxygen. This bracket will apply to oxygen and hydrogen both. So this 2 will applicable to oxygen and hydrogen. So 2 oxygen is here, but we have to count this also. So 3 oxygen this and 2 oxygen is this. So 2 plus 3, it is 5 oxygen. Then hydrogen. This 2 will applicable to hydrogen also. So 2 hydrogen here, 1 hydrogen here. So total 3 hydrogen. Then nitrogen. So nitrogen is only 1. Now towards product side, calcium, oxygen, hydrogen and nitrogen. Calcium we have 1, oxygen we have 2 into 3. This 3 into 2 equals to 6 plus 1. So we have 7 oxygen. Then hydrogen, 2 hydrogen. And nitrogen, this 2 will applicable to nitrogen also. So we have 2 nitrogen. Now if we will see by this, then we have to balance all except calcium. So if we will see here first, the nitrate is 2 here. So let us first balance nitrate. So if we are balancing this nitrate, then we are balancing nitrogen and oxygen together. Nitrate is 2 here. Just don't look at this calcium. We are talking about this nitrate. NO3, 2. So nitrate are 2 here. 2 nitrates are there. So here we have only 1 nitrate. NO3 is 1. So 1 NO3 here, but here 2 NO3s are there. So let us balance this nitrate first. So if we are balancing nitrate here and if we are writing 2 here, then let us count all these things again. Now we have 2 hydrogen and 2 hydrogen. So we have now 4 hydrogen, right? Then nitrogen, we have 2 nitrogen. Oxygen, we have 6 oxygen here plus 2. So 8 oxygen we have. 2 into 3, 6 and 2. So 8 oxygen, and calcium is already 1. Now let us go towards this side. Still we need to balance according to this. So we have to balance oxygen, we have to balance hydrogen. Our nitrogen is balanced now, if you will see, 2 and 2. So we have to balance only this 2, oxygen and hydrogen. So we have 4 hydrogen here and we have 2 hydrogen here. So if we will add here 2 more, here it is 4, here it is 2. If we will add 2 here, so where you can add 2? Here. If we will add 2 here, then we have now 4 hydrogen and how many oxygen? Let us count it again. 3 into 2. So 6 oxygen from here, and this 2 is applicable to this oxygen also. So plus 2 equals to 8. Now if you will see that oxygen 8, hydrogen 4, hydrogen 4. So our equation is balanced. Third question. This is relatively very easy equation. By looking at this equation, you will get to know that which 2 atoms we need to balance. Zinc will react with hydrochloric acid, will give us zinc chloride and hydrogen. Here if you will see that zinc is 1, zinc is 1. The Cl is 2 here, whereas hydrogen is also 2 here. So Cl is 2 and hydrogen is 2. Here we need both the atoms 2 because here they are 1. So if we will simply add here 2, our equation is balanced. Again, whenever we are looking at the equation, so first see what all atoms need to be corrected. So zinc is 1, zinc is 1 here. Hydrochloric acid, here it is there. So 1 hydrogen, 1 chlorine is here. But here 2 chlorine and 2 hydrogens are there. So both are 2, whereas they both you will get here in one compound and it is 1. So simply when you add 2 here, our equation is balanced. Fourth equation. Potassium bromide will react with chlorine and give us potassium chloride and bromine gas. So here this is our equation. Let us note down the atoms of reactants. So potassium, then bromine and then chlorine or bromide or chloride. Here potassium, bromide and chloride. Please try to maintain the sequence how you have written towards the reactant side. The same sequence you have to maintain towards the product side. So whenever you are comparing, it will be easy for you. So we have 1 potassium here, we have 1 bromide here, but we have 2 chlorine here. Here 1 potassium, chlorine is 1, but the bromine is 2. So by look at this, we know that we have to balance bromine and chlorine. So if our bromine is 2 here and chlorine is 2 here, let us go from left hand side to right hand side. Chlorine is 2. So if I will add here 2, then my chlorine will be balanced. Here I will write the new atoms, the number of new atoms. So now my potassium is 2 and my chlorine is 2. It is balanced now. Chlorine 2 and 2 is balanced. But by doing so, I have disturbed the balance of potassium. So I have to balance again potassium here. So here potassium is 2. So now I will balance potassium towards reactant side. So my potassium is 1. So I will add here 2 and I will make my potassium 2. So my potassium is balanced 2, 2. This was earlier. Now my bromine. Let us check bromine. Now my bromine is 2. Earlier it was 1. So my bromine is balanced now. When I balanced my potassium, the bromine is automatically balanced. So my bromine is balanced now. Now let us check for chlorine. 2 chlorine and this was earlier, so 2 chlorine. So my chlorine is also balanced. So this is my balanced equation. 2 KBr plus Cl2 gives us 2 KCl plus Br2. The fifth reaction. By looking at this reaction, you can see that towards product side we have 2 chlorine and 2 hydrogen. Whereas towards the reactant side we have HCl. This both atom together and that too in 1. So we can add here 2 and our equation is balance. How to write molecular equation from word equation. This is the most important type of question which you are going to write in standard 9 exam. Because in standard 10 chemistry, majority of the questions will based on this. So you need to have hands-on experience on this kind of question or this type of questions. So let us understand how to answer this kind of question and how to write a balanced molecular equation in stepwise manner. In my earlier video, we have learned that how we are writing molecular formula for any compound. So our first question is, this is word equation. So the equation which is written in the word format is word equation. From that we are going to write molecular equation, and that too it should be balanced. So first we will write a molecular formula for each and every compound, and then we will see whether it is balanced or not. So first, potassium nitrate. We know what is potassium. It is K. Then nitrate. What is the formula for nitrate? It is NO3. So we have to make a compound formula of potassium nitrate. So potassium, its valency is 1. Nitrate's valency is also 1. So our compound is KNO3. Now let us go towards production. Potassium nitrite. What is our potassium nitrate? Potassium is K and nitrite is potassium. Nitrite is NO2. So both is 1 1. The valency is 1. So it is going to be KNO2. And oxygen. We all know oxygen. Oxygen alone cannot be there. So it has to be O2. So this is our reaction. Now we have to balance it. Here oxygen are 3. Here oxygen are 2 plus 2, 4. So if I am going to add 2 here, then now I have 4 oxygen and 2. So if I am going to add 2 here, then now my potassium is 2, nitrogen is 2 and oxygen is 6. So if I am going to add 2 here, then and I am removing this 2 from here. Let us check. So 2 potassium, 2 nitrogen, 6 oxygen. So 2 potassium, 2 nitrogen, 4 plus 2 oxygen. So this is the correct way of adding 2 here. So this equation is balanced. Again we will check 2 potassium, 2 nitrogen and here 6 oxygen. So here how many oxygen we have? 4 oxygen plus 2. So 4 plus 2, 6 oxygen. So this is our molecular equation, and that too a balanced molecular equation. So the first step is we are writing, this is our first step. We are writing molecular formula for each and every compound. For that you have to remember the ions. Then the second step is we have to balance it. Now let us understand second equation. Our word equation is aluminium plus oxygen will give us aluminium oxide. So first let us write aluminium. Then oxygen. Oxygen cannot be alone, so it has to be O2. Then now let us see the aluminium oxide formula. This is aluminium. This is oxygen. Aluminium's valency is 3 plus 3 and here it is minus 2. So by crisscross method we will get the molecular formula A2O3. So now our equation is Al plus O2 will give us Al2O3. Now this is our first step. That with all molecular formula we have to just write a molecular equation. Now we are going towards the second step, that is balancing of an equation. We have Al and oxygen. Al is 1, oxygen is 2, whereas here Al is 2, oxygen is 3. So how we are going to balance it? Whenever it is 3 and 2, we can always balance it with the multiple of 6. So here it is 2 and here it is 3. So I am going to add here 3. So 3 into 2. Now our new atoms are oxygen are 6 here. Now here if I want to make it 6, then I have to add here 2. So now our new atoms are 6. So oxygen is 6. Here also oxygen is 6. Now I have to balance Al. Al towards product side are 4 now. So here I am going to add 4Al, 3O2, 2Al2O3. So now it is 4. So my both atoms are balanced, equal. So this equation is balanced and this is our second step. Next question. In this equation it has been given that lead 4 oxide. Whenever any element is showing a variable valency, and in that case our question will come like this. So in this, lead is showing variable valency. So here lead's valency we have to consider 4. So here it has been given that lead 4 oxide. That means in this compound lead's valency is 4 and it is plus 4. Whenever you are attending a question for the variable valencies in the equation, in that case, in the question itself, they are going to give you a valency like Fe2 oxide, Fe3 oxide and so on. So you have to make a note of it and use that valency for that particular element. Now our question is lead 4 oxide will give us lead monoxide plus oxygen. So lead 4 oxide. So lead is Pb, oxide is O. So we know that valency of lead is 4 and here oxide is O and its valency is 2. So our compound is Pb2O4. Now towards product side, lead monoxide. Now monoxide means 1 oxygen or oxide is also 1 oxygen. Whenever it is dioxide, that means 2 oxygen is reacting with it. So here monoxide means only 1 oxygen. So lead and oxygen. Lead we know that it is 2, oxygen we know it is 2. So here it is PbO, it is lead oxide. Now oxygen. Oxygen cannot be alone, so it is O2. Now let us write our full equation. So Pb2O4 will give us PbO plus O2. Here in this, earlier it was Pb plus 4 and when the reaction is completed we got here Pb plus 2. So the valency for lead is changed after the reaction will be completed and towards product side we will get Pb plus 2. So now we are balancing this. So here Pb is 2, oxygen is 4, whereas here the lead is 1 and oxygen are 1 plus 2. So it is 3. So let us first balance lead. If I am going to add here 2, my products will change like this. Pb will become 2 and oxygen will become 2 plus 2, 4. So here Pb is 2 and oxygen became 4. So my equation is balanced. How to calculate molecular weight and how to calculate percentage composition for given compound. So let us first understand first type of numerical, that is calculate molecular weight of NaCl. In this type of numerical will be given atomic weight for what all atoms we have used in our compound. So in NaCl we have to find out molecular weight of NaCl. Now what is the difference between atom and molecule? So this is atom of Na, this is atom of Cl. They both will combine and form one molecule. These two are atom. So what all weight they have given, it is for atom. This is 23, the weight of this atom. This is 35.5 is the weight of this atom. In this particular molecule, there are two types of atom. First is sodium, another one is Cl. So whenever you are solving this kind of numerical where you have to find out molecular weight, so you have to add atomic weight of what all atom has been used in that particular compound. And this atomic weight will be given along with the numerical. So here we have Na and Cl. You have to also see that how many atoms are there. Here Na is only 1 and Cl is also 1. So we are adding Na one time and Cl also one time, because they both are 1 in one molecule. So now we are adding them and whatever answer we will get, that will be our molecular weight for NaCl. So our answer is 58.5 molecular weight for NaCl. The next numerical. In this we have to find out, calculate molecular weight of calcium nitrate. This is calcium and nitrate. In this molecule we have one calcium, one nitrogen and one oxygen. And how many nitrogens are there? This is a bracket which, and here it is 2. So this 2 is applicable to nitrogen also and oxygen also. So we have 2 nitrogen. We have 1 calcium. NO3 is like this, 2. So this 2 is applicable to nitrogen also and this 2 is applicable to oxygen also. So nitrogen we have 2 and how many oxygens we have? 3 into 2. So we have total 6 oxygen. So in this molecule we have 1 atom of calcium, 2 atoms of nitrogen and 6 atoms of oxygen. These are the atomic weight for calcium, nitrogen and oxygen. So let us write the molecular formula is this. So now Ca plus 2 nitrogen plus 6 oxygen. Now we will replace this with their atomic weight. What I have done here is number of atoms I have written in the front. So we have to multiply with them. Or you can add nitrogen 2 times. Or you can add oxygen 6 times. I have multiplied here. So calcium is 40 plus calcium is 1. So we are not multiplying it with any number. 2 into nitrogen is 40. Again, if you don't want to multiply, you can add nitrogen 2 times plus 6 into oxygen 16. So this is a short way to add all the atoms, or you can do like 40 2 times nitrogen 6 times oxygen, and this will be your molecular weight. All the atoms we are adding. So this will be your molecular weight for calcium nitrate. So here it is 40 plus 28 plus 96. Now when we are adding this, our answer is 164 molecular weight for calcium nitrate. Coming to the next type of numerical is percentage composition. In this type of numerical, with the help of molecular weight of the compound, we will find out an particular element's percentage composition in that compound. So let us see how to find out. So first of all, in this type of numerical, there are 2 steps. First, you have to find out the molecular weight of that compound, and with the use of that molecular weight, we will find out the percentage composition for each and every atom present into that. So first step is we have to find out molecular weight, which we have seen in earlier time, that how to find out molecular weight. Now second is we will find out the percentage composition of each and every atom present into the compound. So first, which compound we have to find, which compound has been given to us? Carbon dioxide. So this is carbon dioxide. In first step, we will find out the molecular weight. So carbon is 12. How many carbon we have here? Only 1. So 12 carbon plus how many oxygens we have? 2 oxygens. And oxygen's atomic weight is 16. So 2 into 16. So 12 plus 32. So we will get here 44. This is our molecular weight of carbon dioxide. Now in carbon dioxide, this is carbon and there are 2 oxygen combined to it. In this particular molecule, if this is a 100% of one molecule, we have to find out how much percentage of oxygen present into this and how much percentage of carbon present into this. In this we have only 2 types of atoms. So we are finding out for carbon and oxygen. If there are many, then you have to find out for all. For example, if it is potassium permanganate, into that there are potassium, manganese, then oxygen. There are 3. So for all the 3 you have to find out the percentage composition. In this we have to find out the composition for carbon and oxygen. And we always find out the percentage with respect to 100. So how we are going to solve it? For the first step, we are finding out the percentage composition for carbon. So it is going to be the weight of total molecule is 44. So in 44, that is carbon dioxide, the carbon is 12. In this total 44, how much carbon is? It is 1. And what is its atomic weight? 12. So in 44, in the total molecular weight, that is our carbon dioxide, our carbon is 12. If it is 100, then what percentage our carbon is present into this 44? Out of 44, if our carbon is only 12, then at 100, how much carbon will be there? So via crisscross method, we are writing 12 into 100 divided by 44, 27.27%. So in this whole molecule of carbon dioxide, our carbon is 27.27. Now if you will subtract this 27.27 out of 100, you will get the percentage composition of oxygen. But you have to show it via these steps. Now let us find out for oxygen. So for oxygen, in 44 gram of carbon dioxide, oxygen is, how much our oxygen is? The 32. We are not writing here 60 because in the molecule there are 2 oxygen. So we have to write here 32 and not 60. Oxygen is 32. Then at 100%, what will be the percentile of oxygen? You can add gram. So 32 into 100 divided by 44. So our answer is 2.73%. So our oxygen is 72.73%. Now if you will add these two, it has to be almost 100%, which will show that carbon and 2 oxygen, 3 atoms are there into the carbon dioxide, and this are their respective percentage composition. Our next numerical is calculate the percentage composition for KMnO4. So in this molecule we have potassium, we have manganese, and we have total 4 oxygen. 1 potassium, 1 manganese and 4 oxygen. So to find out percentage composition, there are 2 steps. First we have to find out molecular weight, and from the molecular weight we will find out percentage composition for potassium, manganese and oxygen. So one molecular weight and the other 3 percentage composition for these 3 different atoms. So let us start with the molecular weight of KMnO4. It is potassium permanganate. So in this we have 39 plus 54.9 plus 4 oxygen. So 4 into 60. So this is 64. So the answer is 157.9. So we are rounding up this and we are taking 158.0. So this is going to be our molecular weight. Now with respect to this, let us find out first percentage composition for potassium. So percentage composition for, let us make 3 different sections. Here I am going to find out for potassium. So we are going to write like in 158 gram of potassium permanganate we have 39 gram of potassium. Then at 100% how much potassium will be there? So it is 39 into 100 divided by 158. 24.68% of potassium is present in JEEMain. Now for Mn, for manganese. So in 158 gram of KMnO4 we have 54.9 gram of Mn. Then in 100% how much Mn will be present? So 100 into 54.9 divided by 158 and 34.74% of manganese present in potassium permanganate. Now for oxygen. So in 158 gram of KMnO4 our oxygen is 64. There are 4 atoms of oxygen. So we are not taking 60. We are taking 64. 64 gram of oxygen is present. Then at 100, how much? 64 into 100 divided by 158 and our answer is 40.50%. So in percentage composition, the first step is you have to find out molecular weight. Then from that molecular weight and the atomic weight of that particular atom, you have to find out its percentage composition. It is depending upon the molecule, that how many atoms are present into that. So whenever you are finding molecular weight, that many atomic weight you have to add into it. When you are finding percentage composition, you have to find out percentage composition for all the atoms present into that molecular compound.